The argument of z. The argument of a complex number z is the angle between the real axis and a line joining z to the region. We refer to the argument of z as arg z. Right, so let's have a look what it looks like. Again, we start with the argand plane. Remember that I'm doing it in the first quadrant, but it can be expanded into all 4 quadrants. But for explanation's sake, I'm going to work in the first quadrant for now. And let's say that z is here somewhere with the real part on the x-axis and the imaginary part on the y-axis. Right? And by now you know that the distance here is represented by r, which is the modulus of z, indicated by the absolute value. And now for the argument, let's just see it again. The argument of a complex number is the angle between the real axis and a line. So in other words, the argument is the angle between the line and the x-axis. Alright? And this we represent then by arg z. And how do we do this? How do we calculate this theta? If I draw a straight line down to the x-axis, again I have the Pythagorean triangle. Right? And you should know the trigonometric ratios. So we can use sine of theta, which is y over r, or cos of theta, which is x over r, or tan of theta equal to y over x. So it will all depend on which information you have. Right? So remember this distance then, that is the y distance, and down here, that will be the x. So let's look at another example. Calculate arc of z if z is equal to 1 plus the square root of 3i. So let's draw this triangle again. In other words, z has the coordinates of 1 on the x-axis and square root of 3 on the y-axis. So the r is then again the modulus, and we have the origin. So to calculate theta, the argument, we need to find, right, you can choose which function to use. If we go straight to tan, because we know this is square root 3, the length of that side, and the length of this side is 1, right? So we can immediately go to tan of theta equal to, so tan, remember the ratio of tan is y over x. In this case, it would be square root 3 then over 1. And using special angles, tan of theta equal to square root 3 over 1, or you can just use the calculator. And from this, theta is then equal to 60 degrees. Right, we are working in the first quadrant, so it should be an acute angle. If you wish to use either sin or cos, the sine or cos functions, you would have to work out r first. So just for argument's sake, let's do this. R squared is then x squared plus y squared, which is equal to, simplifies to 4, and r is equal to 2, right? So now, from this, if we wanted to use sine of theta, that would be equal to square root of 3 over 2, or if you used cos of theta, it will be 1 over 2. But all of these then, we have, from all of this, we have that theta is equal to 60 degrees. So, for my final answer, I want to write the argument of z is then equal to 60 degrees. Make sure that you always answer the question.